In this question, there is a function, and then it's a quadratic function up to x power 2. So you express that it's a parabola. That means it's either it should be open upward, so it should be like this. Now a is different value, so maybe different value of a, then the graph may shift left or shift right or go up, go down. You are not sure. And then PQ are the vertex of the graph. So we are not talking about this function, but there is some function related to this. If this is the original function, maybe there is some another function related, maybe like this, you're not sure. And then they say that P is the vertex of the transformed function. That's at least you know that this is the knowledge that we have to show we know about this, about the transformation of function. But anyway, just in part A first. Part A is typical. We are going to use the method of computing square, which means we have to put all the x. I can't accept two terms with x. I'm going to group all the x within a perfect square. So the rest of them will not be affected by x, and then we can get the minimum value easily by the vertex form. Just like what we have mentioned, we are going to put all of them into a complete square. So I have to analyze it into this format. We have x squared minus 2 something something. The first something must be x because they should be the same. So x and x. Now you have to guess what you have to put inside in order to make this one consistent. That means you can't change the value. So negative 2, of course, we have to times 2a. Then now I know what is missing. I have negative 2ab. I need something square, so I need plus something which is 2a squared. I can't change the value, so I have to minus 2a squared immediately. Afterward, these three terms is our target. It is already formatted to change to a complete square. So I just express this something minus something squared. The first item is x, the second item is 2a. Afterward, I just need to handle the residue. So we have minus 4a squared plus 3a squared minus 1. For the moving term, we have x minus 2a bracket squared. For the constant fixed term, we have minus a squared and minus 1. And the nature of square create a turning point. The minimum of this part is just 0. It can't be negative. That's why we have a turning point here. So for vertex, when what inside the bracket x minus 2a equal to 0, that means x equal to 2a. Then y will become negative a squared minus 1. So we get the vertex. And don't write down the vertex of y equal to fx. We are talking about this graph because in this question there are 3 vertices in total. So it's equal to when x equal to a and also when y equal to negative a squared minus 1. After that, in part B, they ask about PQ. PQ is the new vertex after some transformation. Of course, we want to know where is PQ so that I can make good use of the distance between them. And then therefore, later on, there is a point something like this. So we draw it properly first. And then y equal to fx. And then there is another line. Y equal to fx minus 1 and then outside minus 1. So what inside the input will affect the x-axis, will affect the input. And for the input, minus 1, which means that later to achieve the result, that means it will shift to right hand side, 左加右減. So it's become right hand side as an intermediate result. Afterward, we have minus 1. So the whole curve, the height will decrease by 1. It shifts down by 1. So final outcome may be like this, with the vertex here. To conclude, that means the vertex go right by 1 and then go down by 1. So from this vertex, go right will become 2a plus 1. And then go down will become minus a squared, minus 1, minus another 1. So minus 2 in total. Similar reason, we are going to consider another curve now. This curve become y equal to negative f bracket x minus 1 and then outside plus 1. So there are three effects in total. The first effect affects the x-axis. 左加右減, so it's the same as before. It's later to achieve the result, so it will become right hand side. And also this time is flipped. The height will be negative value, so it's reached to this point, and then it's flipped. The curve may become like this. And finally, we are going to +1, so we will move up this point. So now the final curve is like this, and Q is here. Beware that the vertex are also from the original vertex go right by 1. So this is on the same vertical line. They are in the same column. So this is 2a plus 1 also, while the height from negative a squared minus 1, negative, become positive a squared plus 1. And then plus 1 outside, so finally become a squared plus 2 in total. This is a squared plus 2. Now we group all the data that we have. Just like what we have mentioned, PQ is a vertical line, so it's extremely easy to get the length between P and Q. Since PQ is equal to 12, so the difference of their y coordinate is equal to 12. So we have a squared plus 2 minus negative a squared minus 2 bracket is equal to 12. We have an equation related to a, so we can now log the value of a. 2a squared is equal to 8, a squared is equal to 4. So a can equal to 2 or a equal to negative 2. When we have two values, see whether we can reject one of the results. They say that a is a positive constant, so this one will be rejected. Without the sentence, theoretically a can be any real value, so it's fine to accept negative 2. But in this case, they say positive, so we just simply reject it. We just need to handle one case. So we have another coordinate, negative 4, 0. Because I want to know their related position, maybe we find out that they with the same height or same x coordinates. So we better update the position of P and Q first. Therefore, P is 5 and negative 6. Q is 5 and then positive 6. And there is a coordinate R, negative 4, 0. Now the problem is S is our oval center of PQR. It seems like we better redraw the graph to have a more accurate position. So P go right by 5 and then go down by 6. P here. And then we have Q here. And then there is a point R. R is 4, 0, negative 4, 0. So maybe somewhere here. Triangle PQR. So we are going to connect Q, R, and P. What is the meaning of oval center? That means from any vertex, we draw a perpendicular line to the opposite side. So from point R, we draw a perpendicular line to QP. Just like what I mentioned, this is vertical, so this must be horizontal line. So the x-axis is the perpendicular line from R to the opposite side already. Now we have two more lines, then we can find out the intercept. That means the oval center. So from Q to PR, we also draw a line which is perpendicular to RP. So the intercept point here is our target oval center. You may also add one more line from P perpendicular to RQ. But basically, any two lines intercept is enough for us to spot out the position of oval center. The oval center is labeled as S. And then because it's lying on this line, that means the horizontal line, we know that the y coordinates must be 0. Now the problem is what is the x position. So I let it be h0. Let S become h0. I know the y coordinates but not x coordinates. Then I just need one more line if I have equation of this line from P to the opposite side perpendicularly, I let this line be L. Then I expect is y equal to something x plus something. And then we just put one more situation is when y equals 0, what is corresponding x, then I can write down the position of s. That means we solve the simultaneous equation of this horizontal line and also this line. You can also choose this line, but only any one is okay. So L here, in other words, that means a straight line pass through P, and then with a certain slope which is perpendicular to our Q. So the first thing is pass through P, 5, -6. The second thing is I want to get the slope of L. We write down the meaning of L first. We can write clearly that L is a line pass through P at the same time such that is perpendicular to our Q. Whenever we say perpendicular, you know what I mean. So slope R Q, we get this one first, then we try to get slope L. The slope R Q between R and Q, that's why you should copy down the coordinates in vertical manner. So 6 minus 0 over 5 plus 4 is 6 over 9, that means 2 over 3. Therefore, slope L is equal to -1 divided by 2 over 3. It's -3 over 2. Then you can write down the equation of L. L is equal to any point, general point xy, y minus passing through point P. That means y minus plus -6, y plus 6 over x minus 5 is equal to -3 over 2. We have this equation. Then we have this line, and then we just log the value when y equal to 0. Or you may start replacing y equal to 0 here, then may be easier for you to handle. So 0 -3x plus 3, and x is equal to 1. It's quite consistent with our drawing. Obviously, our answer must be between -4 and 5. And then we have x equal to 1. So don't forget to write down the coordinate of s. S is when x equal to 1, y equal to 0. And then a more difficult part, they say that there is a circle pass through P and S is the center. So there may be a circle like this, pass through P and S is the center. Beware that S is on the x-axis, and then this is a perpendicular bisector from S to this point. So therefore, when it's passed through P, at the same time it should pass through Q also. But anyway, in this question, it's not that important. We have a straight line. L is the tangent to C. That means there is a straight line. Tangent to C, that means touch this circle any point. At P, that means we are talking about a tangent touch this point. So there should be a straight line like this. And then this is our target tangent. They say this is L. It's quite impressive that we have L already, so we better change our answer just now. We label it as L1. And then we are going to find out L, this line, extend it, and you will cut the x-axis at point T. So we extend this line, and then it cuts the x-axis here at point T. And then they ask PQ, is that PQ is the perpendicular bisector of angle RPT. So basically, it's asking along this vertical line, is left and right symmetric? Is this line and also this line symmetric? Distance between R and S is equal to 9. So if the distance between S and T is equal to 9 also, then they are angle bisector, they are symmetric. If not, then they are not symmetric. But anyway, if you're trying to find the position of T, it's definitely not difficult. Just simply remember the property, radius perpendicular to tangent, which implies that we have a perpendicular line here. This is perpendicular. So we can just simply say SP perpendicular to L. Since SP perpendicular to L, the slope SP, we get it first, is equal to -6 minus 0 and then 5 minus 1. It's -3/2. So slope L is equal to -1 divided by -3/2. We get 2/3. So this is parallel to RQ here. Because this angle is 90, also this angle is 90. So based on interior angles, then these two are parallel. That makes sense. And then again, we just need the equation of L this time. Our point pass through this, so again we prepare xy general point to express it. Y plus 6 over x minus 5 is equal to 2/3. Basically, you don't need to tidy up, and then we just need to consider the situation when y is equal to 0. So when y equal to 0, x equal to 14, so this is 14. Now the difference is 14 minus 5, we have 9, so basically this distance and this distance are the same. Therefore, left and right are symmetric. You know that this is angle bisector. T is 14, 0. And then in order to express, maybe you can let this point be PQ out as, maybe this point is V, so let V is this position, 5, 0. Since PQ is our vertical line, so compared with x-axis, they're perpendicular. Angle RVP and angle TVP should be the same, equal to 90 degrees. So we can apply the trigonometric ratio. For this angle, now the question basically is asking, is this angle and this angle are the same? And then we may consider tangent angle RPQ. That means we consider this angle first. Is equal RV to VP. RV is 9 while VP is 6, so it's 9/6. As you like, whether you simplify. And at the same time, tangent, another side, is also the same, angle TPQ is equal to 9 to 6 also. Therefore, angle RPQ equal to angle TPQ. That's how you can express the answer clearly.